This video covers using linear equations to solve problems about calculating interest. We'll use this example to go through the background information. We want to know with these problems that it's actually implied we're talking about investing for just 1 year. So if we know how much money is invested, let's take the 3,000. It's invested at 4%, so we'll multiply by the decimal 0.04. There are formulas for calculating interest. This simple interest has the formula: the amount of the interest equals the amount that is invested, the principal, times the interest rate, and then times the time. But we're assuming that we're investing for only 1 year, that t equals 1. So our formula is simplified to just interest equals principal times the interest rate. And that's why we're using 3,000 times 0.04. We can take care of this calculation pretty quickly, 120. Now we're finding a total interest, so let's go to the next account. It's 5,000 that's invested at 5%. And this product is 250. So we found the interest from each individual account. We'll just add them up to find the total interest. For this problem, $370. Now as we set up our problems, we're going to take this approach. Account by account, we want to identify the principal, the amount invested, and the interest rate. And that product will give us the interest. Over here we've got another principal times rate. Now these problems are sometimes solved using a table. That's not my preferred method, but I want to take one moment just to show how my approach is similar to using a table. Most tables will be set up this way. We'll have a row for each account. We've got 2 accounts in this problem, and spaces for us to fill in the principal for each account and the rate for each account. And in this column we'll show the product to find the interest. We have the formula written above the table, so it's clear what each box represents in terms of the quantities. To fill in this table for this problem, the first account will be $3,000 at 4%. The second account, $5,000 at 5%. Now that we've filled in the known information, we can multiply across each row to calculate the interest. There's where we would find the $120 from the first account, $250 from the second account. We want to be cautious about how we can interpret a third row of this table where we might put our total. We can definitely say that if $3,000 was in the first account and $5,000 is in the second account, that's a total of $8,000 invested. And we can sum the interest as well. $120 from the first account, $250 from the second, there's our total, $370. You need to be aware that we cannot add the percents to find our total rate. Those percents depend on the reference value, which means that if the principal is different for the 2 accounts, we really can't do very quick work with combining the rates. We can't do a quick average. We definitely don't want to add them. It's actually more like a weighted average. And if we did want to figure out, well, what was this final rate that would show $8,000 invested to equal $370 of interest, we'd actually have to set up a separate formula for that one. Principal times rate equals the interest. So if we're trying to find the rate, we can solve this formula for R. Divide both sides by P. So the interest rate would be the amount of interest divided by the principal. We're basically saying what fraction of the total principal, $8,000, is this part that we calculated, 370. And then we'll change that into a percent. The result is an interest rate of 4.625. Now in these mixture problems, the total rate must be in between the rates of the individual accounts, because we actually are getting an average. It's a weighted average. So we weighted the 5% more because there was more principal in that account. And that's why our final rate is closer to the rate of the account number 2 than it is to account number 1, because there was more money there, so our average rate is closer to the 5%. Now we may look at another table in one of our future problems, but for the most part we're going to just set up an equation where we think of each individual term being made up of the principal and the interest rate for that particular account. And when we add those up, we can find the total interest. Let's take a look at our next example. A total of $6,800 is invested. It is divided into 2 accounts. One account has a 6% interest rate, the other has a 2.5% interest rate. How much is invested in each account if the total interest is $273.75? Remember how we want to set up our equation. We want each individual term on the left side of the equation to represent the amount of interest for each account. That means we'll need to multiply the principal, the amount in that account, by the interest rate. We'll do that for each of these two accounts, and since each product is calculating what is the interest from that account, when we add them all up, we'll get the total interest. This is part of our standard approach to these problems. We're calculating total interest by calculating interest for each individual account and adding them up. And the way we calculate individual interest, principal times interest rate. Now let's identify what information the problem is giving to us. We see the total interest, $273.75. There's our quantity for the right side of the equation. We also have the interest rates for each account. The first one's 6%. The second one is a 2.5%. Remember, we're always moving that decimal point 2 places to change a percent into a decimal. So 2.5% is 0.025. Now we don't have right away the amount into each account. We don't know the principal. We know that a total of $6,800 is invested, but we don't know how that is split up into the two accounts. So there's a very important idea at work here for how we can use a variable to represent these two unknown amounts. Let's take a moment to break down this approach. This represents the total amount of money that we're investing, $6,800. Now we don't want to say we're evenly splitting it up, so $3,400 into each account. We can't assume that it's evenly divided. All we know is that from this total, we're going to take some part of it out to put into the first account. And we'll use a variable to represent this unknown, x. So up here, we're going to use x to represent the unknown amount of dollars put into account number 1. We don't want to use a separate variable for account number 2. That makes the problem a little bit more difficult to solve. What we can do instead is say, if from that $6,800 we just took away x to put into the first account, what would be left over? How much money? Well, from the $6,800, we subtract x to put into the first account. That is how much is left over, and all of that is going into account number 2. That's how we want to represent these two related unknowns using only one variable. And in fact, to write the principal, we'll need this expression, 6,800 minus x. Okay, so this is the approach when we know the total amount, but we don't know how it's split up into two accounts. We'll say x dollars goes into one account. Well, how much would be left over for the other? Take our total and subtract out x, and this expression represents the number of dollars in account number 2. Let's take a few quick examples just to show how this is working. Let's say that we put $1,000 into account number 1. If we had a total of $6,800, you would know that there must be $5,800 left to go into account number 2. And if we look at 6,800 minus x, if x is 1,000, then definitely that's how we're calculating the 5,800, subtracting 1,000, the amount that's in account number 1. What about if x equals $5,000? $5,000 into the first account. We know that that would leave us with 1,800 left over for account number 2. We're taking the 6,800, subtracting how much is going into the first account, and left is what goes into the second account. So we see that it works with a few examples where we plugged some numbers in, and we want to know that we can take this approach when x remains unknown, just using the variable x. 6,800 take away x would be however much money is left over for account number 2. So we'll use this equation to find x, the amount of money in account number 1, and then we know we can use 6,800 minus x to find the leftover dollars in account number 2. Real quickly, if you said, could we put x for account number 2 and then 6,800 minus x for account number 1, absolutely. That would give us the same final results for the principal in each account. What's key is that we've decided to represent these two unknown principals one using a variable x, the other one total minus x, whatever is left over after we subtract out x, the amount we're putting in account number 1. The next steps for solving this equation would be to multiply the principal times the rate. We do have this variable x in there, so the first account can only be called 0.06x, the result of multiplying x times 6%, 0.06. Be careful about this second account because we're using two terms here to represent the principal. That means when we multiply by 0.025, we must distribute. We must make sure that we're multiplying the 0.025 to each of those two terms in this expression. The 0.025 times 6,800 equals 170. 0.025 times minus x, or negative x, minus 0.025x. And now we'll finish with the right side, but I noticed a quick typo to fix. The interest should be $273.25. So sorry about that. But there's our right side, $273.25. Now let's settle into our usual approach for solving linear equations. First, on the left side, do we have any like terms we can combine to simplify this left side? And we have a 0.06x minus 0.025x leaves us with 0.035x. I'll bring down the plus 170, and it equals, the right side, 273.25. We're continuing to solve for x. We'll subtract 170 from each side. Leaves us with 0.035x on the left. On the right, taking away 170 leaves us with $103.25. And the last step to solve for x, divide by 0.035. And we get x equals $2,950. Now x was being used to represent the principal in account number 1. So now we know that the $2,950 represents the principal amount of money in the first account, which is the 6% account. How much is in our other account? We had been using 6,800 minus x as the expression to represent that amount, but now we can actually calculate the difference. 6,800 minus x, now we know, is 2,950. So we'll subtract and see that we're left with $3,850 in account number 2, the 2.5% account. So we've answered the question in this problem, how much is invested in each account? Let's go through another example of a problem like this so we can become accustomed to the flow through these problems. Here's our next example. A total of $2,750 is invested into two accounts, a 4% account and an 8% account. How much money is in each account if the total interest is $157? So again, let's try to find a principal and an interest rate for each account, multiply the principal times the rate for each account to give our total interest. We've got a 4% and an 8%. Principal, it's another example where we know the total, $2,750, but we don't know how this is split up into the two accounts. In these cases, we can make one principal x, an unknown amount, and what would be left over for the other account would be our total, 2,750 minus x. Same approach that we had in the previous problem. We know the total, we don't know exactly how it's split up, so x dollars into the first account, the leftover, 2,750 minus x, into the other account. Next, we'll distribute and simplify the products that we have in these two accounts. From the first account, just 0.04x. The second account, again, careful that we are going to distribute. 0.08 times 2,750 gives 220, and 0.08 times negative x minus 0.08x equals our right side, 157. Now let's find the like terms and combine. 0.04x negative 0.08x equals negative 0.04x. We'll bring down the plus 220 equals 157. We're solving for x, so next we'll subtract 220 from both sides. It will cancel the 220 from the left side, and 157 minus 220 on the right side equals negative 63. Last, we'll divide both sides by negative 0.04 to finish solving for x. $1,575. Now X was the amount in our 4% account, and the 8% account was $2,750 minus X. And now we know that X is $1,575. So this difference, $2,750 minus $1,575, leaves us with $1,175 in the second account, the 8% account. Now really quickly, let's take another look at how the table would be used with this problem. I'm going to try to squeeze a table right into this space here so that we can still see our two final answers and see the equation that we set up. So you'll see how using the table is the same as this form of an equation that we're using. Now this is what the table would look like. We have rows for each account and columns to show principal, rate, and the final interest, result of multiplying principal times interest rate. We know account number 1 has a rate of 0.04, 4%. The second account is 0.08, 8%. We would be taking the same approach for representing the principal, in this case where we know the total, $2,750, but we don't know how it's split up. We would choose one account to use X for the principal. The other one would be $2,750 minus X. Once we have those spots filled in, we can multiply across these rows. In account number 1, we would see the 0.04x. Account number 2, we'd have to be cautious again here that we are distributing when we multiply these two terms in the principal by the rate 0.08. So we would distribute and get 220 from the 0.08 times 2,750 and minus 0.08x from multiplying 0.08 times minus x. We can fill in the bottom row for the total in these two accounts. We know there was a total of $2,750 invested, and we know the total interest, $157. Now once we have the table filled in, we're usually looking at the column for interest to find our equation. The interest for account 1 added to the interest for account 2 would equal the total. And that is exactly the equation that we have right here. So the table is just a helpful way for us to set up the equation, and my preference is to skip the table altogether and think about each term as a product of principal times rate. Some people might prefer to use a table to set it up. I prefer to just think term by term, principal times rate. Either way, it takes us to this equation that we solve and get to these two results.